Hi, I have created Heimdall mainly because I wanted to have a really lightweight monitoring system um, to essentially monitor my home lab. Everything started with the need of essentially having simple metrics that you would get from top or btop is streamed through a centralized location in my home lab. Instead of having me to SSH into several machines, I essentially wanted to be able to see all those metrics from within the centralized location. So then I decided to create Heimdall to help me with that. Um, I used another tool that I created called Maple, which is a set of AI agents and skills to help me accelerate the process or my development process, and it follows proper software development life cycle. So it creates helps me to create documentation, wireframes, and all that kind of good stuff. Without further ado, this is about Heimdall. So let's go over it, right? Let's essentially start here my terminal so I can show you how it actually works. And I'm gonna use it on live mode and then also demo mode. So let's use the live mode, and I'm going to start the Heimdall dashboard using the hub auto. This is actually using zero conf, so it's going to use MDNS to be able to look for the actual hub. And as you're going to see on the documentation, everything is decoupled. So the hub is the main um, it's the main system that will hold all the information that we need and collects metrics from the daemons that runs on the hosts and makes it exposable through the dashboard, which is a TUI, the CLI, which is a new feature that I'm working right now, and also through TSDB, so time series databases. Granted, TSDB is not a requirement for Heimdall. Um, However, um, you should be able to set it up and configure TSDBs within Heimdall itself, so then it can actually stream data to a TSDB and from a TSDB as well. So without any further ado, let's start the dashboard. Sorry, this was the help. My bad. That's because I just uploaded or updated the binary here. So that's the dashboard. As you can see, there's a fancy splash screen. So in terminal emulators such as Ghosty, Kitty, Alacrity, that's gonna show up as the image. If you're using terminal um, or some other terminal emulators that are not as feature flagged, then you're gonna see the ASCII art. Okay, so as you can see, it's pretty basic here. I have all the hosts I have pre-configured so far running on my home lab. So I have my Casio OS here, which is Captain Canuck. I have my MacBook Pro, which I'm recording this video, my wife's Mac Mini, and my Pro Max GB10 or DJI Spark. Uh, so from within this view here, there are a couple of things we can do. One of them is filter. So we can look for the machine. So let's say I can type can, and then you can pull it up. Press escape to quit the filter, and you can also navigate through groups. So I can hit J, and it's going to cycle through all the configured groups. There are pre-configured groups, and the extra ones, which are dynamic, are based on tagging or how your daemons are actually providing the tags back to the hub, and you can have many. So hub is a default one, and that's because Heimdall supports federation. So you can have multiple hubs reporting to a single hub, and then your dashboard will be able to aggregate all these hubs into a single hub, display that on the dashboard, um, and for sure you can group them by hub and also look and search for the hubs. If I hit G again, we're going to cycle through OSs. So you can see my Casio OS, two instances of Darwin. Those are my two Macs, and my Ubuntu, which is the Pro Max GB10. I have other computers that I have not subscribed to the hub yet. If I hit G again, it's going to cycle through my first tag, and that's the dynamic one. I call it ENV. Three of the machines are not actually setting any tags, so they go as no ENV, whereas my actual Casio OS, I actually have tagged it as ENV equal remote workstation. And that's why you see it right here. And if I tag it again, if I cycle through it again, um, it goes all the way to the end of all my my possible groups, and it just turns off grouping. And that's the basic view. You can see the state of the host, the CPU, memory, disk, temperature, GPU, and power. And that's essentially everything I was looking for. Uh, but then I started to have a couple of extra needs, such as I want to have more details about a host. So if I go here to my Pro Max GB10, for example, and I hit enter on it, now I'm able to see extra details, like a super minimalistic version of btop, if you will. Here I can actually check its CPU, memory, disk, GPU, VRAM. In this case, it's not showing up because it's unified memory, power consumption, temperature, the CPU cores that are in use and how many of them, and some of the hardware specs, including the network interfaces. And then I can see the actual ping to the internet and the actual local ping as well. So then I can measure how well or how healthy is the connection between this box and my gateway, and how healthy is the connection between this box and the actual internet. And then from this screen, I can actually navigate through many hosts. Important to note that Heimdall was built to be backwards compatible as well, and that's done through versioning of the schema. We're mainly relying here on protobuf and gRPC. So if I navigate up and down, I can actually cycle through the various hosts that I have here pre-configured instead of pressing escape and going back to the list. So pressing down, I'm already on the last host, so pressing up, I go to my wife's Mac Mini, and then you can see all the specs and everything else. You can also see that she's running the Demon version 1.4. I can go to my MacBook, which is the computer I'm recording it. You can see it's running the version 1.2. So really, really behind, but we can still stream everything here in terms of data. And now I can go to my CacheOS, which is running the latest version as of this video, which is 1.6. And now we get two extra tools that I included on this 6. So remember that I mentioned that I want Heimdall to be really, really lightweight, uh, with kind of mimicking a really, really lightweight version of btop and whatnot. But also, I figured that having access to logs and a top functionality would help me out to drill down into what might be happening within these boxes if some of these are actually in a really red threshold. So by pressing L, I can actually see some of the logs that are pre-configured within the host. So you can configure the logs based on tagging as well. So you're going to see in the documentation that you can provide multiple log files to it, and you can prepend with tagging. So then if there are many here, we can actually see them all below the sys. So if I click on it, and if the host was to write to the log file, we will be able to stream that back to this dashboard. If I go back and I press T, I have top, just like you would run top on your Unix, Linux, Mac, whatever machine you're using. And here you can navigate through all the processes, and then you can see actually memory consumption, percentage, CPU, and whatnot. Right now, it's a little cumbersome, but it does the job that I wanted to. I'm working on two things as well, actually three things. One is within this top feature on V2, we're going to be able to define sorting. So then you can sort by CPU, memory, whatever really you want to sort. By default, is going to be sorted by CPU consumption. And once you select the sorting, that's going to be persisted into disk. So then the next time you load this up, it's going to remember your pre-selected sorting. And you can change that, and it always persists to disk. The other one is whenever you go to the logs and you enter your log, let's say there's many, many lines of logs here, we should be able to do searching. So then you can search, and then it's going to show you whatever you're looking for plus the timestamp. So this is going to help me to debug, let's say, Open Web UI on my Pro Max GB10. So then I should be able to see whether we're running out of disk, and then if there's any informative log messages, or if my GPU is always on maximum, then I can look at the logs and see perhaps if I'm streaming that log, I can perhaps see what Llama CPP is doing, what kind of models are actually running, if there's anything stuck, if it's always reaching error 500 because we're running out of context, whatever it is the case, right? You get the deal. And then top will also allow me to see which processes are consuming that much. And as you can see, it's all centralized through the TUI. Okay, there are a couple of other features that we're working on, such as changing the connection type to socket to consume even less bandwidth. Um, and then this would support also some sort of bi-directional communication. So then the hub can also talk to the daemons and ask for extra information. So instead of the daemons continuously streaming the logs like they are right now, we can ask that at real time. Okay. And any other type of information. Um, that said, security is also a priority here. So let me actually quit this and enter the demo mode. The demo mode, I should be able to show you the extra features that we have as well before I go into the documentation. So as you can see, the DJX Spark has a red flag here, and that's because we can also configure alerts. So whenever you're initiating the hub, you can predefine a few metrics that the hub will be watching for. It could be CPU, for example, here's at 87%, so it's going to start alerting that on the TUI. Not only that, you can also configure webhooks, right? So as much as it's helpful to see that on the TUI, maybe you want to dispatch that information elsewhere. So then you should be able to trigger that through the webhook. As I mentioned, this also has TSDB connection, so you can export that to Grafana or any other time series. The hub also provides endpoints that are Prometheus compatible. And again, I wanted this to be super lightweight and still really lightweight. The demons, they consume less than 20 megs of RAM. The dashboard, as it is right now, consumes like anywhere from 25 to 30 megs, so it's still pretty lightweight. And these are all optional features. If you don't enable them, you don't use them, right? Um, but yeah, this is pretty much your demo. You can navigate through all this stuff and whatnot. Um, yeah, it's nothing crazy. The demo is using mock data, by the way. Now, if we go to my VS Code and we look at the documentation, there's a couple of other stuff that we have in here. If we go through the quick start guide, not only you can see the installation process, which it's literally a curl command. You execute the curl and you're able to pick whether you want to install the daemon, the helper. I'm gonna get into the helper soon. Um, the hub or the dashboard, and in the V2 also the CLI. Or you can just use your favorite AUR package manager, Yai, Paru, and you can install that if you're running an Arch-based system. But again, the curl command will install it for you, no big deal as well, on your Mac, on your Linux, no matter what it is. And then these binaries, they also provide self-update. So if you type Heimdall dash daemon space update, it's gonna look for the latest version and it's gonna update that for you as well. So a couple of things here, right? Uh, on Let's go to the main README so I can show you. We have a list of Kickstart guides. There are a couple of things we can do. You can monitor a fleet of hosts. So let's say I have a hub here at home um, on my home lab, and then I have another hub on my home office. Same physical space, right? So same network, but I want to separate them between two different hubs. You can have my office actually communicating to my office hub, which could be Raspberry Pi, whatever box you have it, or even your computer that I'm recording right now. Then you can have another hub on the basement, let's say, and that those two hubs they can talk to a unified hub, and that's essentially it's gonna essentially enable um, federation as well. So let's go to monitor a fleet. You can watch many hosts from one stations, right? So click on the monitor a fleet, and then here you can see the actual architecture, um, and it's pretty basic. There are a couple of options that you can provide as dash options. If you don't provide any dash option, and you just execute the binary as is, Heimdall will actually provide you with a configuration tool within the terminal, kind of like a next finish kind of setup that will help you to set up um, your application, whether that's the hub dashboard or even the daemon. Or it can provide that through dash parameters, whatever suits your need. Maybe you're programmatically installing this through an orchestrator, so then you can actually use dash parameters. More importantly, whether you use dash parameters or whether you use the configurator, it's going to actually persist the configuration to disk. Okay. So the next time that you want to execute just the binary without anything, it's actually going to pull the configuration from disk. And that decision was made because then you can also just push the JSON configuration to the hosts you might want to talk to a specific hub or something like that. So everything here is programmatic and highly customizable and also backwards compatible. As we saw in the demo, you can run different versions within the same hub and exposing that through the dashboard, including the dashboard's backwards compatible. So the dashboard can receive data from lower versions, but also a lower version dashboard can receive information from higher versions. It's just going to be missing a couple of features here and there. Uh, Here, as you can see, we can provide a couple of options, including where the hub is listening and which port and whatnot. But you can also enable so the hub itself is self-discoverable through zero-conf. So if you initiate Heimdall hub uh, in the zero-conf modality, you don't need to specify many of these configurations. It's going to make itself available through MDNS. And then it's the same thing with the daemon and the dashboard. Um, if you do a dash dash hub auto, it's going to be able to look for this self-discoverable hubs. Long story short. But if you want a more pragmatic way or more secure way, whatever you want to call it, you can actually specify the address of a given hub to your daemons, to your dashboards, whatever. More importantly, you should also identify your computer whenever you're running the demo, so then we can actually reply on the or represent that computer within the dashboard as well through the name. And again, as I mentioned, all of these options they get persisted in the JSON file. Okay. And on the documentation, we have a couple of other things that you can go through, including the zero conf option that I mentioned. Okay. And that's on monitoring a fleet. You can tag your hosts, as I mentioned on the demo. You have multiple tags and whatnot, and that becomes dynamic groups within the grouping functionality, um, etc., etc., etc. Okay. Um, Now, going back through a secure deployment, right? And that's mainly because if you start enabling all of this, let's say you are in a corporate environment, this essentially will make that anyone that's running a dashboard can connect to it, or literally anyone can scrape it, right? And that's because, and that's the main reason why we made it so Heimdall can support tokens. So let me open this here in this view. So we've rendered a markdown. It can support connection tokens, so then only the hosts and dashboards with that token can connect to a specific hub. And we also support TLS, so we can run the communication between the hosts and the hub, or the hosts and the hub and the dashboards all secure. Uh, so this is all made with security in mind, and we have the whole set of configurations here. By default, no configuration is created whatsoever. No security configuration is created whatsoever, but we have the ability to configure all of these, long story short. And this again ensures that the connection between the hub and the hosts, the hub and the dashboard are secure, if you will, and they also provide some level of authentication. And it's important to note when I mention hub to daemon, hub to dashboard, because hub is the only one that will have proper connectivity. The dashboard connects to a hub, the daemon connects to a hub, but nothing else connects to the dashboard or to the daemon itself. Right. So the hub is literally what the word means. It's a hub. Um, you can also use the same security configuration for federation. Okay, and we're gonna go through federation soon. There's also privilege metrics. So when I created Heimdall first, I wanted this to run a daemon that's unprivileged, no sudo, no nothing. So collecting everything that's within that user's ability to pull in terms of metrics. And this is mainly for security reasons. Some of the OSs, they actually need sudo to be able to report on specific metrics. That's why we also created a Heimdall helper. So your daemon, which connects to the hub, always runs with the unprivileged user. And then you have a helper, let's call it a sidecar, that runs on your host as well as sudo. And that has no internet connectivity, has no network connectivity whatsoever. It uses a sock connection between the daemon and the helper. And that's how the daemon will have the ability to pull some information from some systems that require sudo to have access to. And here we have a list of things that some systems that might need actually the helper to run with. And then here we just go through the documentation, and it's going to tell you exactly why you might need some privileges and why you don't want to run the daemon as sudo. Going through federation, let's render here as well. Uh, this essentially shows you the Bifrost. So by now you kind of know the theme of the project already, but it shows you the Bifrost where it can have multiple sites talking to a single hub, and that's what I mentioned a couple of minutes ago, where I can have site A running on my basement, site B running on my home office, and they all talk to a centralized hub. So whenever I connect to my dashboard, the dashboard only talks to that centralized hub. Nonetheless, now that you saw that we support TLS, and authentication or some level of authentication, you can have the central hub sitting elsewhere. It could be a different location that's not my home, right? For instance, I'm running this over Tailscale as well, so I can remotely access all those machines and see what's happening with them. I could technically deploy this to another location and have a site-to-site VPN, whatever you want to call it, or if you're brave enough, you can deploy the central hub to the cloud, if you will. Granted, you got to configure all the possible security configurations you might need to ensure nothing gets exposed, but the ability is right there, right? And then again, that's mainly the basic feature of federation is to ensure that multiple sites that can combine into a single hub, so then your dashboards talk to a single hub. And as I mentioned, the hubs are also one group as part of the wheel, so you can cycle through different hubs. We also have the control plane. I'm not going to dive much into it. It just explains how the whole thing works within the hub itself. We have log streaming that I mentioned that we're also working on V2 to have it searchable. Uh, so then here you should be able to stream various logs, and then you can actually navigate through the specific aliases. Demo mode, not going to cover it because I just run the demo mode. That's more for if you want to develop or if you just want to see what Heimdall looks like. We also have metrics export, and that's actually really nice. So we have Mimir, which is the ability to expose some of these metrics to Grafana using TSDB as well, because we do have the ability to connect to TSDB, and Prometheus. So we provide the actual endpoints, and it's all queryable through the hub itself. And pretty much all hubs they will expose this, uh, as long as you have the proper port configured on the metrics listen, right? So uh, you can expose this just through one hub. Let's say you're a corporate, so then you have Prometheus installed locally, and that uh, you don't need to enable that on your cloud that we mentioned before, for example, or other sites. Or if you want to, all these metrics to get aggregated into the centralized hub, and then you can expose that through the centralized hub as well on the federation configuration. And last but not least, alerting. So as I mentioned, and as I showed on the demo, we also have the ability to configure alerts. Uh, so here, um, we do have a sample JSON file with a couple of metrics, and pretty much all roles are within the same JSON file. And then all you got to do is to configure Heimdall Hub with the set of roles you want. And if you want to dispatch this to a webhook, you can also configure here the webhook, if you will. So then these alerts are actually dispatched through the webhook as well. Yeah, but that's pretty much it. These are all the configurations. I'm currently working on the V2. I published the ADRs already, so that's going to be through socket connections to minimize even more the bandwidth consumption, so the network bandwidth, and a couple of extra features that I mentioned, such as the sorting and the filtering. Uh, as mentioned, this was built using Maple, which is yet another project of mine. Okay, so it's my um, AI orchestration tool, let's call it. And that's just so I can rely on AI to help me with documentation and testing. So AI helped me a lot with putting the proper documentation in place, checking for grammar and all that kind of good stuff, ensuring that things are acceptable from a human standpoint. Um, Whenever I wrote the actual architecture um, stuff, it also helps me as a validation. So I actually write the ADRs and it acts as a rubber duck to help me validate my approaches. It helped me to also write the wireframes. So I have here wireframes in Markdown. I also have wireframes in XCollyDraw and everything else. So it helps me design the UI, long story short. And also helps me with user stories, right? It's literally following the way how I like to develop proper software development lifecycle. So then here you can see all the user stories with the gherkin and everything else. Um, I I do have Cucumber here, but to be honest, I haven't implemented the step definitions yet. As you can see, I'm a little lazy. Um, but it's not to say that it does not have tests. I'm using this just for stories. We do have tests within the code. Okay, so here you can see on adapters, we have all the tests and everything else. And also, as I mentioned on the architecture, I wrote all these ADRs. I do have an ADR template if people wants to submit PRs and whatnot. Oh, oops, did I close it? Yeah. And then you can see here, for example, on the very first version, which we were discussing gRPC, I expressed all my wishes and then I used Maple as my rubber duck to validate my approaches. Ultimately, the decision is mine on what we do, and I rely on AI again for rubber ducking and for testing, right? But again, yeah, this is Heimdall, created again because of a basic need, um, and decided to give it away to the open source community. Yeah, thank you very much.